So hello everyone, welcome to another video on Internet of Things. In this video we are going to start a new module, that is your module 2, and we are specifically going to talk on this topic on interoperability in IoT. Okay, so this topic is based on this paper, Interoperability in Internet of Things, Taxonomies and Open Challenges by Mehdan Ora, Mohammad Atiquzzaman and Martin Giatke. Right, I hope I have spelled this name properly. Anyway, let us proceed with this topic. All right. So, what is the definition of interoperability? So, that is the first thing that we are going to see. So, organization like ISO, IEEE, they have defined interoperability in a different way. We already know what interoperability means, right? This is a very common word. It means that different things, they can operate among themselves. So that is what interoperability means. But then these are formal definitions that are given by ISO and IEEE. So let us look at that. What is interoperability? ISO IEC has defined interoperability as the capability to communicate, execute program, or transfer data among various functional units in a manner that requires the user to have little or no knowledge of the unique characteristic of those units. Okay, so various functional units, they can communicate, execute program interchangeably, then transfer data among themselves without one functional unit knowing about the internal detail that increases the unique characteristic of the other functional units, right? So that is how they can communicate, they can execute program, they can transfer data, and that is how they can operate among themselves. Okay, so that is how they will have this interoperability. Then IEEE, they have defined interoperability as the ability of two or more systems or components to exchange information and to use the information that has been exchanged. So yeah, different components, they can exchange information and use this information. So if we have that, then we can say that we have this interoperability. Okay. So why do we need interoperability? Okay. So there is this project called Unify IoT. It's a European project. They have recognized, they have identified more than 300 different IoT platforms that are available in the market currently, and new platforms are being developed as time passes, right? So there are 300 and new ones are being developed. So each of this platform, they have their own infrastructure, they have their own proprietary protocols and interfaces, and among all these different platforms, they have this incompatible standard, format and semantic, right? So all these platforms have their own infrastructure, protocol, interfaces, APIs, and this infrastructure, protocol, APIs, they are not compatible with one another. So one platform's API is not compatible with another platform's API. So they have this incompatible standard, format, semantic, which does what? This creates a closed ecosystem. Okay, so this closed ecosystem, they are also called stovepipes or silos. Okay, so what will happen is that if I say I have some Cisco based system without interoperability, then in my closed ecosystem I will be forced to use only Cisco based solutions. Okay, so say at some other point of time I want to use this Siemens based solution. If there is no interoperability between this Siemens and Cisco, I will not be able to use this Siemens based system. So I will be closed in this ecosystem of uh, Cisco, right? So this is what will happen if there is no interoperability. Nevertheless, the need for IoT interoperability, this is rising rapidly every day. Okay, why? So there is this American company. It's a management consultation company. It's McKinsey. Okay, that company has done an analysis on the market, and they have determined that this lack of interoperability in IoT devices, that is a big threat to the projected growth of IoT. Okay, so they have given us this figure that IoT, okay, uh, is this IoT market is suffering to the extent of 40%. Okay, they could have maybe profited 140 rupees, they are profiting 100 rupees. So why is this lack of profit arising? This is because of the lack of interoperability. Okay, so this is not something that I am saying. This is a result of a analysis done by a big finance management consultation firm, right? It's a McKinsey. So all these reasons, okay, this motivates us to create solution. This motivates us uh, to make our IoT system, this different IoT system, interoperable among themselves. Okay, we have more reasons for interoperability. That is, we have two perspective over here. Okay, from the perspective of IoT providers, lack of interoperability means that service providers are bound to the IoT devices or software offered by a single provider and must stick with it, which may bring the potential risk of higher operation cost later on, as well as product functionality and stability issues. Alright. So lack of interoperability will do what? It will make these IoT providers stick to one ecosystem. Okay. So they will have to stick to one provider. So they cannot use devices from other providers, because in that case their entire system, if they have two different devices from two different providers, they will not be compatible with each other. They cannot operate among themselves without interoperability. Okay, so this will do what? This might be risky for the IoT provider, because later on it may result in higher cost of operation. Okay, as well as product functionality and stability issue may arise if they are stuck with only one provider. Okay, now this is the perspective of IoT provider. Another perspective is from the perspective of application developer. Application developers perspective is this: incompatibility between IoT platforms results in adapting their application to the platform specific API and information model of each different platform, which prevents cross platform, that is application which operate on multiple platform, and cross domain application development, that is application which combine different domains. So what this is saying is that from the perspective of application developer, without interoperability, okay, what will happen is that the application developer will have to write their application for all these different platforms, right? So what will happen is that if you write a program for Arduino, you will not be able to run the same program in, say, some other things like 8086, right? So that is one more problem because of interoperability. Okay, so this programming itself is not interoperable between 86 and Arduino. So this is one more problem. We will have to rewrite our software. So for this reason also we need this interoperability. Someone should give us this interoperability so that we can write for one platform and we can deploy in lots of platforms. So this interoperability, at least in the case of mobile application development, is very stable right now, right? So we have things like Cordova, PhoneGap. Okay, so if you write your app for PhoneGap platform, your app will be automatically compiled for Windows mobile, Windows operating system, then Android, then iOS. Okay, so you don't need to write for each of these different platform. So that is a interoperability provided by a third party, that is your PhoneGap, okay, or Cordova. So this is interoperability. Okay, so this is the perspective why application developers, they seek interoperability so that they can write once and deploy in all these different devices that they have. Okay, so with that they can create cross platform application. Okay, and once they are able to create cross platform application, they can go ahead and create cross domain application, that is your application that spans over several domains, like maybe an application that looks at the your car, your vehicle, and also your smart home. Okay, your smart vehicle and smart home, these are two different domain, but now we can have a meta application that will, because of this interoperability between this vehicle domain and smart home domain, we can have a meta application that will manage both of these different domains. Okay, so those kind of inter-domain application, cross-domain application is also possible if we have interoperability between all these different IoT devices. Okay. So this is one more reason why we should aim for interoperability. All right. Next is, what are the different perspective of looking at interoperability. So what are the different taxonomies that are there in this interoperability in IoT? So our devices, we should aim such that our IoT system, entire system, we should aim so that we have device interoperability. We should have network interoperability, synthetic, semantic, and platform interoperability. Okay, so these are all the different type of interoperability that we should aim to have. Alright, so let us look at each of them one by one. Device interoperability. Okay, so what is this? IoT is composed of a variety of devices called smart object or things, which may consist of high-end devices like Raspberry Pi smartphone, or low-end devices like RFID tags, Arduino. Okay, so we may have these high-end devices, these low-end devices. They should be interoperable among themselves. All right, and apart from that, we may have various communication protocol. Okay, have emerged due to the different requirements of IoT markets. For example, IoT devices such as smart TV support traditional Wi-Fi technologies and 3G, 4G cellular communication. Medical devices are based on ANT plus standard. Wearable devices may use Bluetooth Smart or NFC. Then environmental sensors may use Zigbee based, which is based on IEEE 802.15.4. Okay, so all these different devices may have all these different connectivity technology, right? So all these different devices running on this different connectivity technology, they should also uh, be interoperable. So that is one more aim that we have. All right. Device interoperability refers to enabling the integration and interoperability of such heterogeneous devices with various communication protocol and standard. So these heterogeneous devices, high and low end devices, with these different protocol, communication protocol and standard, making them integrating them together and making them interoperable among themselves. This is device interoperability. Okay, device interoperability, we are concerned with two things, that is the exchange of information between heterogeneous devices and heterogeneous communication protocol, and the ability to integrate new devices into any IoT platform. Okay, so these are the two objectives that we have when we aim to have device interoperability. All right. Next is network interoperability. Okay, IoT devices generally rely on various short-range wireless communication and networking technologies, which is rather more intermittent and unreliable. So our IoT communication, that is unreliable, lossy, based on very constrained network devices, very low energy consuming devices. All right. Moreover, this network that IoT devices will be operating on will be heterogeneous. All right. So somebody is using Bluetooth, someone will be using Zigbee. So it is heterogeneous, it is multi-service, multi-vendor, and largely distributed. So it will be distributed. Our networking devices will be provided by multiple vendors, and there will be multiple services available to us, and they will be heterogeneous. Right. So this is some constraint, these are some problems that we have in IoT regarding network. So all these different type of networks should be interoperable among themselves. Right. Network level interoperability deals with mechanism to enable seamless message exchange between systems through different network. So all this Bluetooth network will be there. One SCATARnet may be a network of using Bluetooth. Another might be a Zigbee network. Another might be a 6-low WPAN network. So all these different network should be connected together. So it is going to be a network of network, okay, for end-to-end communication among all these devices. So that is what this network level interoperability should give us. All right. Next is synthetic interoperability. Synthetic interoperability refers to interoperation of the format as well as data structure used in any exchanged information or services between heterogeneous IoT system entities. So all these different IoT objects, these IoT things, they will talk to each other. So the data structure that they use to communicate should be same. Okay. So all the format and data structure should be same so that they can communicate with each other. So this is synthetic interoperability. All right. So if say one is sending data in XML, another is sending data in JSON, so our server is expecting data in CSV. Okay. So this is going to be lots of synthetic error. This is synthetic error. Okay. When we try to parse, say our server, our sink is expecting data in CSV. Okay, it will have a grammar for CSV. Now when somebody gives me XML data, I will have parsing error. Okay, so if I have this parsing error, then it is synthetic error. All right. So how do we resolve that? We should have the same encoding rule. Okay, we should have the same syntax. We should communicate with the same syntax. A interface needs to be defined for each resource, exposing some structure according to some schema. Okay, so there should be some schema that tells us how do we need to send this data. So this schema can be specified using WSDL or REST API. Okay, the content of the messages that we are going to send needs to be serialized, and we need to send it in a format. Okay, the content of the message needs to be serialized to be sent over the channel, and the format to do so. So there should be some standard format like say XML or JSON. Okay, the message sender encodes data in a message using synthetic rules. So when I send message, I will encode the message in using some synthetic rule that will be specified in some grammar, that will be given by some grammar. Now the message receiver will decode the received message using synthetic rules defined in the same or some other grammar. Okay, if the grammar that I used to send the data, the same grammar is used to decode my message, okay, then I will not have any synthetic problem. If some other grammar is used to decode the message and I am encoding it with some grammar, with some other grammar, then I will have this synthetic mismatch, right? So synthetic interoperability problem arises when the sender's encoding rule are incompatible with the receiver's decoding rule, which leads to mismatching message parse string. Okay, so when I say grammar, once again I am talking about context free grammar. Okay, so we can define XML, we can define JSON, and all this thing using CFG. Okay, so we should have some grammar. It's not necessary that you specify CFG in CFG style. Okay, the way you did in formal automata, you don't need to do that, but then you should have some rule, okay, that I will encode in this manner and my receiver will decode in the same manner. Okay, so this interoperability among the sender and the messenger, if we have that, then we will not have synthetic error. Otherwise we are going to have synthetic error. All right, so next is semantic error. So W3C defines semantic interoperability as enabling different agents, services, and application to exchange information and data and knowledge in a meaningful way on or off the web. So enabling these different agents, services, application to exchange data, information, knowledge in a meaningful way. So essentially semantic wants to give meaning to your data. So in synthetic we have already talked about that we will decide on some format, okay, to send our data. If we have different format, say receiver is expecting JSON and I am sending XML, then that is going to be synthetic error. But then say both of the receiver and sender we have both decided that we will send data in this CSV format, okay, comma separated value format. So what is happening? Let us say I have some, I am sending temperature and humidity, okay, uh, and the receiver is going to receive this temperature and humidity. I am going to send temperature and humidity in this format. I am going to write temperature 15 degree, comma, I am going to write the humidity say 90%, okay. So I am going to write 1590, okay. Now if this is something that I am sending temperature comma humidity. But if my uh, receiver, that receiver is expecting humidity comma temperature, okay. So what do I have? I am sending temperature comma humidity, receiver is expecting humidity comma temperature. So I am sending a integer comma integer, receiver is receiving integer comma integer, okay. Receiver was expecting integer comma integer. So there is no synthetic error, okay, but there is semantic error, because the first value I was sending was temperature, receiver was expecting the first value to be humidity. So there is semantic error over here, okay. So although we are sending in the same format, okay, but the data model and schema used by different sources are dissimilar and not always compatible, okay. So if this data model and schema is different, then we will have this semantic error. Moreover, this data may be represented in diverse unit of measurement and consist of other information, like I may send my data in Fahrenheit and the sender may expect the temperature data to be in Celsius. That is also going to be a synthetic error, okay, sorry, semantic error. This semantic incompatibility between data model and information model results in IoT system not being able to dynamically and automatically interoperate, as they have different description or understanding of resources and operational procedures, even if IoT system expose their data and resources to other. So even if IoT systems they expose their data, they make their data available to other, okay, uh, we may still not be able to use this data if we do not know the semantic meaning of this data, okay. So if two devices they don't agree on the semantic meaning of the data, then there cannot be interoperability among these two devices. So semantic incompatibility arise out of this problem, okay. So this is semantic interoperability. Next is platform interoperability. Okay, platform interoperability issue in IoT arise due to the availability of different OSs. For example, we have this Contiki OS, RIoT, Tiny OS, OpenWS, and OS. Okay, so lots of diverse OSs may be there. Lots of programming languages, data structure, architecture, access mechanism will be there for this data and all these things, okay. So because of this we will have platform interoperability. For example, Apple HomeKit, okay, it supports the uh, programming language Swift. Google supports the programming language Weave. Amazon supports embedded C and Node.js. So if I write for Apple HomeKit, okay, using this language Swift, my application will not be readily portable to Google Brillo or Amazon AWS IoT platform. Okay, so this different platform they have their own different languages, they have their own different API, they have their own different architecture. So I will have to create my application over and over for all these different platforms if there is no platform interoperability, okay. This non-uniform causes hindrance for application developer to develop cross-platform and closed domain IoT application. So this platform incompatibility, this non-uniformity, this is a problem if we wish to create this cross-platform or cross-domain application, right. So after cross-platform interoperability is enabled, cross-domain interoperability can be achieved in which different platforms with heterogeneous domains are federated to build horizontal IoT application. We will be looking at, yeah, this is what it says. See, this is say our platform 1. Okay, this is working in say your healthcare, your smartwatch that is looking at your how many steps you have walked, then your say blood sugar measuring device that you have. Okay, so all this may be domain 1 running on some medical based platform. Okay, so this is your domain of healthcare. Next is your vehicles will be running on another platform. Okay, so all these IoT devices in your vehicle will be another platform. Then maybe you have this smart home, your smart light. Okay, all this different maybe platform C. Okay, smart home based platform. So that will be your domain smart home. Okay, so all these different domain, they will contain different devices. Each of the domain will contain different devices running on different platform. These devices running on the platform C, these devices on platform B, these devices on platform A. So all this will be there will be some form of a cross domain interoperability. Okay, so all these different domains will cross to work together if we have this cross platform interoperability. Okay, so all these different platforms running different domain, they can work together and we can have this meta application, super application that manages all these different domains. For example, my healthcare, my car, and my house, using one application. So those kind of application will be possible if we have this interoperability among all these different IoT platforms. All right, so these are all the different interoperability. This is this diagram that you see on your screen. This sums up all the things that we have been talking till now. Okay, so what are the different type of interoperability? There is device interoperability, and that is in device, what are the different type of devices? They are based on capability. We may have low end and high end devices, and these devices may be running different communication protocol. Okay, synthetic devices, this data exchanging devices, two devices that are exchanging data, they may have different data format, different schema, different interface. Okay, that would give rise to synthetic interoperability. Semantic, data model, information model, ontology may be different. Okay, we will be looking at what is ontology. Okay, uh, then there might be platform interoperability issues that would be given by, that would arise out of having different operating system, data structure, programming language, and different application development that we wish to do, like cross platform and cross domain application. Okay, so if we want to create cross platform application, then we need platform interoperability, right? So that is one more issue. Then we have network interoperability. Maybe we will have wireless network and wired network, and they will need to communicate. So that would be networking interoperability. All right, so how do we handle these different interoperability challenges that we have? So here are 7 solutions that are provided. One is to use adapter or gateway, another is to use virtual network or overlay based solution, that is create a virtual network on top of your network. Then we have some network technology based solution. We may have open FPI, we may have SOA, we may have semantic web technologies, and we may have open standard. So let us go ahead and look at each of them one by one. Okay, so adapters, these are gateway, also called adapter or mediators. They address interoperability through the development of an intermediate tool to improve interoperability between IoT devices. By, so this gateway, they address interoperability. They act as a intermediary tools between these different devices. They act as a bridge between these different devices, and they will translate all the specification, data, standard, all these different things. Okay, so and between these middlewares, so we will have two different standard. This bridge will translate from one standard to the another. So we may have MQTT on one side, we may have XMPP on another side. Okay, so what will happen? This XMPP messages, if I want to send to some MQTT based device, this gateway will translate this XMPP protocol, this packet on a XMPP protocol to a MQTT protocol. Okay, and vice versa. So this is what a gateway will do. It will translate protocols. Okay, gateway address interoperability through the development of an intermediate tool to improve interoperability between IoT devices by acting as a bridge between different specification, data, standard and middleware, etc. To perform a conversion between the protocol of the sending device and the protocol of the receiving device, the gateway can be expanded with the use of plugins. So say right now I have my gateway is capable of translating between XMPP and MQTT. Now at some other point of time, say I want my gateway to be able to translate between COAP and MQTT. Say okay, so I will be able to augment my gateway. I will be able to expand my gateway by writing some plugin software for my gateway. Okay. So, for example, when IoT devices use dissimilar communication technologies, for example, Zigbee and Bluetooth, or when they use dissimilar application layer protocol, for example, MQTT and XMPP, so in that places, the gateway will be used. Okay, so different communication technologies, say between Bluetooth and Zigbee. If I want one Bluetooth device to send data to a Zigbee based device, I will have some gateway. That gateway will be enabled with both Bluetooth and Zigbee. The gateway device will receive my Bluetooth message and send it over Zigbee to the Zigbee device. Okay, so this is what gateway should do. Gateway can be dedicated hardware, or the function can be embedded in the firmware or software of an intelligent device such as PLC or computer. So gateway can be dedicated hardware, okay, or it can be just a program running on some PLC or on some computer. Okay. Okay. Now triple T. If this then that, and Ponte are examples of these adapters gateways. Okay. For example, Ponte is a framework which enable publish and receive of data from sensors and actuators through M2M protocol. Okay. So PONTE allows different sensors and actuators to talk with each other through this RESTful API, through a REST API. It allows different devices running on HTTP, COAP, MQTT. Okay, so all these devices running different protocol, they can communicate with each other through this PONTE content. Okay, so this is a gateway framework that we have. Okay, in IoT. Next is network, virtual network or overlay based solution. So what is this? This is managed ecosystem or network object. So this is the name of a paper solution, MENO, MENO, with the aim to integrate sensors and actuator and other IP smart objects seamlessly to the internet for end-to-end communication. So they aim to integrate sensors and actuators and other IP based devices to the internet for communication, end-to-end communication. The main idea here is to create a virtual network on top of physical network and thereby allow communication with other type of devices including sensor node. So basically your physical network will run on different communication technology. For say some devices working on Bluetooth, some on Zigbee. Now on top of these networks I will create a virtual network. Okay, and this virtual network will be used to communicate. So your real physical network below, some people are using Bluetooth, some people are using Zigbee, not a problem. My virtual network that I use to communicate will be the same. Okay, the real physical actual network below is not significant anymore for me. So within each virtual network, end-to-end communication is possible using different protocol. Once end-to-end communication is enabled, it becomes possible for application developer to write new application that utilize sensor actuators and other devices. So once again, we will have this virtual network that will be made up of real physical networks, and each of these physical network can provide end-to-end communication. Okay, we can always create some transport mechanism. Okay, transport layer like mechanism. We can have error checking and all those things. Okay, so end to end can be guaranteed, okay, by an application developer himself. So end to end is possible in each protocol, and with this end to end build on this real network, we can have this virtual network on top of this real network. Okay, so the concept utilized by Nemo, it is used in IoT VN, so Internet of Things Virtual Network. is a real implementation of the concept laid down by Menu. Okay, so this is virtual network, that is overlay based solution. Next, we have different networking technologies, protocols and technologies that have been used to provide network interoperability in IoT. For example, this conventional universal plug and play and DLNA protocols are used for communication between IoT devices and gateway. So these are protocols that we have, that are used to communicate between these IoT devices and gateway. Okay, so how do we enable this networking technology? How do we enable this interoperability in network? There are four solutions given. One is IP based approach, second is SDN, third is network function virtualization, and fourth is fog computing. Okay, IP based solution is this. IP based solution embed the full TCP/IP stack on smart devices. By embedding TCP/IP stack, the sensors and actuators are directly connected to the IP network to allow end-to-end communication between sensor network and IP network. Okay, so if we have this full stack TCP/IP stack, okay, full TCP/IP stack in our IoT devices. So this is possible in low-end devices using things like we already talked about. UIP is there, UIP v6 is there, BLIP is there. Okay, so this can be used in low-end devices to provide full TCP/IP stack. Okay, so if we have this TCP/IP stack, then our uh, devices are connected to the internet. Okay, and if our devices, all these devices are connected to the internet, then there is no problem of communication. There is no problem of communication. All of them can communicate with each other through TCP/IP. Okay, so key benefit over here is that gateway is not necessary. Gateway and protocol translation is not necessary. So if all of them are using TCP/IP, then we don't need gateway or protocol translation. Okay, but this is not always possible. Why? Because there are devices that cannot run even this full stack, this lightweight full stack TCP/IP stack. Okay, so in that case we use things like routing over low power and lossy network, ROLL, or 6 low WPAN or COAP. So all devices cannot run TCP/IP. So these alternatives, they have been provided. If we use this alternative, then this approach will use gateway to convert between standard protocol used in the internet and protocol used in the sensor network. So if our sensor network is running say 6 low WPAN, then we will need a gateway to translate between this 6 low WPAN to this IPv6, for example. Okay, so if we use full TCP/IP full stack, then no gateway is necessary. But if we use this constraint protocol like ROLL, 6 low WPAN, COAP, then we will need some gateway to translate it back to IP network. Okay, TCP/IP. So between TCP/IP and our 6 low WPAN, we will be needing some gateway to do this translation. Okay. Next solution is SDN. SDN has been used to allow different objects from different network to communicate with each other using IPv6, and at the same time simplify the management and control operation of various objects by adding an additional IoT controller over the SDN controller. Thus, even so the devices have different protocol. The forwarding devices in the router convert it into a form understandable by the receiver. This enables communication of diverse devices in the network. So in SDN has been modified for IoT. We already talked about SDN. So SDN, if we have different devices, different running different protocol underneath, SDN flow table can be modified in such a way that when I running one particular type of networking technology, I want to send to another networking technology, my packets will be modified before sending to that network. My packet will be modified so that it becomes compatible with that network. Okay, so this is what SDN can provide us. Then the next solution is network function virtualization, NFV. NFV separates the physical network equipments, so all these different equipments that we have, NAT, firewall, from the functions that run on them. This way, numerous service providers can create several isolated virtual networks which can then share the physical networks equipment provided by the network infrastructure provider. So, network function virtualization will do what? They will also enable interoperability among different networks. How? They will use all this, they will create virtual network. Okay, like before, we saw one solution, virtualized network based solution. So, this is similar kind of virtualized solution, but here what they are doing, they are using one firewall. Okay, and this one firewall will be used by different virtual network. Okay, so we have only one firewall and that is used by different virtual network. So all these different devices, all these different network devices connected to all these different networks, they can use the same firewall. So this is one more way some interoperability is given. Okay, NFB has the potential to reduce operational expenditure and capital expenditure cost by sharing the network infrastructure, scaling on the fly, and flexible network function deployment. So this is what we have. Uh, it can reduce expenditure, operational and capital expenditure, by sharing the same network infrastructure. We will have the same network infrastructure and all these different networks will be there. Okay, physical infrastructure will be same, but different virtual network will be there on the same physical infrastructure, and that will enable all these different devices running different on different what virtual networks to communicate amongst themselves in one virtual network, right? So this is providing in interoperability. Okay, so in a way, uh, this is providing interoperability in the sense that previously we would have had different uh, networks, physical network for all this. Instead of this virtual network, we would have had different physical network that would have required uh, physical investment, right? Infrastructure investment. But now because this physical network is the same, but we have virtual network, so uh, some form of interoperability is given between this network infrastructure and these devices, right? So that is something that is provided. So NFV does what? It enables sharing of network infrastructure, it enables dynamic scaling, and it enables on the fly and flexible network function deployment. So network functionalities can be deployed on the fly and in a flexible manner. Okay, it can scale very easily dynamically, and then this infrastructure they can be shared. So this is a advantage that is given by NFV. Okay, last thing is fog computing. Fog computing is basically this. One more way of providing interoperability is all these devices will send data to the cloud. Okay, all these devices they will be connected to the cloud and they will send data to the cloud. And when say device A and device B they want to communicate, how will they communicate? Device A will send to the cloud and device B will get this data from the cloud. So there is no direct connection but through the cloud. Okay, what fog computing does is this: it brings the technology of the cloud to the edge devices. Okay, now all these routers and switches, previously we said that they are just forwarding device, they do not do any processing. Okay, but nowadays research is being done so that these edge devices, these routers, uh, switches which are very near to me compared to the cloud, these routers, these edge devices are nearby to me. Okay, so these devices will enable me to do processing. Okay, so the cloud has been used as a medium to address interoperability called the fog of things, where the computing, storage and network services are placed at the edge of the network rather than centralized cloud server. So in normal cloud computing, we would have sent to the cloud server. Now instead of sending to the cloud, we send to some intermediate this device. Okay, this is now acting as a cloud server. My router, which is very near to me at the edge of my network, so that is my cloud device right now. So this is fog computing. This decreases network latency that arises when converting the raw data produced by resource constrained mobile devices and sensors into knowledge or actionable question instruction. So this decreases network latency, okay, which would have been used by converting this raw data produced by these resource constrained devices and sensors. So if I send to the cloud and I get back from the cloud, it will use a lot of time, right? So sending to the edge of my network, sending to the router and getting from the router, that is going to be faster than sending to the cloud and getting back from the cloud. So the latency decreases. All right. So fog computing, we will be looking at fog computing in details on unit 4. So we will talk about fog computing later on in the course. Alright. So next solution is Open API. With the massive development of IoT platform providers, a vast silo of diverse API has been created that increases the difficulty of developing application as well as interoperability issues. Okay. So what is happening is that all these different platform, all these different services, they are releasing API. Okay. Using this API, using some particular platform's API, I can write application for that platform. Okay. Now all these different platforms, they have all these different type of API. So because of this, it is very difficult to make application for all these different platform. Okay. I will have to use these different APIs to write for different platform. So this is a development issue. Okay, this is the issue for developers, and this issue give rise to interoperability issue. Okay, so that is one problem that we have. So how, what is the solution? So HyperCat is a project. Okay, HyperCat is a specification which provides synthetic interoperability among different APIs. So different API, they will have the same syntax. So you go from one platform to another platform, your APIs will stay the same. The way the API look will stay the same. So there will be this synthetic interoperability among different API. Okay, so that is provided by HyperCat, and they provide interoperability between different APIs and services based on catalog that are tagged with metadata. So there is a catalog of API, and this catalog contains metadata about this API, and they provide this synthetic interoperable APIs. So you use HyperCat's specification, you write for one platform. Using this specification, you can write now for the same will be portable to some other platform. Okay, so this is one solution. Now two more projects are going on. One is Symbol TE and Big IoT. They are working on generic internetworking API that provide uniform access to resources of all existing and future IoT platform to address synthetic and cross-platform interoperability. So this Symbol T and Big IoT, they are working on developing API. Okay, general internet networking API. So this API, if they are implemented by all these different platforms, so that will enable that will give us standard API. So if we use this API, then we will have cross platform interoperability. Say platform A is giving me this API. If platform A and platform B, both of them have the same API, then if I write some software for platform A, I can easily put that, I can compile and run it on platform B as well. Okay, so this is what Open API, these different projects like HyperCat, Symbol T, then Big IoT, they are working on this. Okay, to provide this platform interoperability. Next is SOA. So SOA is one good solution. So instead of worrying about API, instead of worrying about all these devices, okay, all these devices, all they will simply expose service to us, okay, to the application developer, and the application developer will use these services without knowing about what is inside. Okay, so without knowing about how these devices work, how these devices uh, are implemented, okay, without knowing all these internal details, the service there that are provided by this device, that will be used to create bigger application. Okay, so bigger services. So this microservice architecture provided by SOA that can be applied in IoT to provide interoperability. Okay. To provide synthetic interoperability between heterogeneous devices and across all systems, researchers have proposed SOA. In the SOA of IoT, the interaction with and operations of different wireless devices are classified into different service components, and the application layer software can access resources exposed by devices as services. So these different devices, they will uh, expose themselves as services. Okay, and application developer, they will use these services to create their application. Okay, exposing each component functionality as a standard service can significantly increase the interoperability of both network and device. Okay, so both these devices and both this network, instead of working with inner details of these things, now they will be available as services when we will be using these high level services. Okay, without going into the black box, without looking what is inside. Okay, so this is one more solution that is proposed. The last solution is this semantic web technology. Okay. Originally, semantic web technologies, it was developed by W3C, such as using technologies such as RDEF, Spark QL, old web ontology language. So these are actually invented for the web. So semantic means to give meaning to data. Okay, to data on the web. That was the original idea behind semantic web. Okay, so the same philosophy is used in IoT. Okay, we will see an example of semantic web of thing. Okay, what is semantics in this context of IoT, we will see that with an example, and moreover we will have one extra lesson, we will have one extra video on this semantic web of things. Okay, semantic in IoT. Okay, the semantic web of thing paradigm is proposed for the integration of the semantic web with web of thing. That is for realizing a common understanding of the various entities which form the IoT. Like what is web of thing? Let me tell you that. Like we have the internet, and on internet HTTP gives us web. Okay, so HTTP is the application layer protocol. The web of thing is conceived as a application layer protocol in the IoT. Okay, so instead of internet we have IoT, instead of HTTP we have WOT. Okay, so this analogy is a good example of understanding what is WOT. It is making this internet of thing devices available on the web. Okay, through a HTTP like interface. So what is semantic web? Semantic web gives meaning to data that is on the web. Okay, so that is done using something called ontology. So we will see that with an example in this video. On a later video we will go into depth and understand how these things are done. Okay, so ontology in IoT are a set of objects and relation used to define and represent an area of concern. Okay, so different device. So let me give you an example. In English language we have studied this thing, right? Subject, verb, predicate, form of sentence. So there is something similar between this and that. Okay, so say we have this example. Let me give you an example. Our cell phone displays meme. Okay, so cell phone and meme, they are two different objects and they are related by this property of displays. So cell phone is used to display meme. So this relation, okay, between cell phone and meme, and this relation that is displays, this together is an ontology. Okay, so once again we will look at this in depth later on a later video. Okay, they represent an abstract technology which aim to hide the heterogeneity of IoT entities, acting as a mediator between IoT application provider and consumer, and to support their semantic matchmaking. Okay, so many ontologies have been proposed in the context of IoT, such as W3C, Semantic Sensor Network (SSN), IoT ontology, SAREF, and OpenIoT. Okay, so we have, sorry, so apparently my spyware protection is over. Anyway, uh, uh, so what I was saying is this: these ontologies, okay, they will now give meaning to our data that is generated by IoT. This ontology can be used to give meaning to data. So this is an example of ontology. This is semantic SSN ontology. Okay, so what do we have? It's look at this. This is a diagram representation of this ontology. So transducer is a M2M device. Okay, controller is an M2M device, sensor is an M2M device, actuator is an M2M device. So these M2M devices, they do what? They observe some feature of interest, they produce some measurement. What is a measurement? Measurement has name, some string, has value, some observational value, okay, has date, some kind of date, has some type, has some unit. Okay, so all these devices, these are object of interest over here. Okay, this one and this one is our object, and these two objects are related by this property. Okay, so this is the relation between these two objects. So these are all defined using ontology. This is basically giving meaning to all these different things. To giving meaning to what is sensor, it's a M2M device. What is the M2M device? It observes some features of interest, it produces some measurement. What is a measurement? A measurement has some observational value. Okay, so all these meanings are given using ontology, and we can describe this ontology using languages that have been developed. Okay, in SWOT it is based on XML. The language is based on XML. So by writing XML like markup, we can describe these ontologies. Okay, and by writing this ontology, we can give meaning to this to our data. So if we give meaning to our data, and this meaning is given with the data, okay, some other device can get our data, can understand the meaning of the data, and can use our data automatically. Okay, so this will uh, give rise to semantic interoperability among these different devices. Okay, so these different devices, they will understand each other. So that is something semantic web technologies aim to do. Okay, so before we end, let us look at a few challenges in interoperability in IoT. Okay, most of the surveyed IoT proposals focus on interoperability from a specific perspective rather than providing interoperability among all the mentioned perspective. So we saw this different perspective. Uh, so device interoperability, network interoperability, synthetic, semantic, right, and platform interoperability. So all the solution that have been proposed, they only focus on one perspective, okay, rather than focusing on all the different perspective. So that is one problem that we have. Okay, then the next problem is this: an ideal IoT platform would offer a pool of standardized communication protocol where the device manufacturer may select the appropriate protocol. Okay, so a ideal platform, IoT platform, will have lots of uh, standardized communication protocols. Okay, however, in the absence of de facto communication protocol, not all smart devices implement all these communication technologies. It is crucial that a standardized protocol is established for all devices. So this is one more problem. So Raspberry Pi, for example, has Wi-Fi and Bluetooth. Now some other device may have Zigbee and something else. Okay, 6LoWPAN. So there is no standard. Nobody has given us some de facto standard that these are the communication protocol that has to be implemented across all devices. that all IoT devices must implement this communication protocol. So without this standard, okay, different manufacturers are creating different uh, are using different communication protocols. So this is one more problem, right? We need one standard protocol that will work across all devices, that will increase our network connectivity, interoperability. Even the most popular IoT platform do not consider edge computing paradigm for speed and efficiency. So even all this fog computing that we talked about. So this is relatively a new area of research, and all these solutions that have been proposed, they do not consider this kind of uh, solution that are available nowadays. This edge computing, fog computing, all these are not considered when designing the different interoperability solutions that we have. Okay. So one more challenge is this. Today's IoT platform almost all provide a public REST API to access the services. However, most platforms use custom REST API and data model, which makes mashing up of data across multiple platforms difficult. Okay. So one thing is good that all these different platforms, okay, they provide REST API. So API are provided in a RESTful manner, but then the problem is that all of them give different REST API. Oh, okay. So all of them, their APIs, although they use the same protocol, that is REST, okay, but still all of them give custom API, and this API are not uh, interoperable among themselves. Okay, these data models and REST API, they are not interoperable, they are not compatible among themselves. So this is one more problem that we have. Then the next problem, to enable an IoT ecosystem, the interoperability framework should consider connecting more than two platforms together. The current solution do not scale to a group of IoT platform and only consider specific scenarios. So these platform interoperability solutions that we have nowadays, most of the solutions that are suggested, they group together only a limited number of platform. Okay, so for example, this PhoneGap, Cordova for smartphone, they provide solution for iOS, Android, and Windows. Okay, but then BlackBerry OS is not provided. Symbian is not provided. Okay, so there is no solution that works, that integrates all the different platforms. Okay, so this is one more problem that we have. Then next challenge is this: the interoperability should be made possible irrespective of underlying technologies. Okay, so no matter what is the underlying technology, they should be these devices should be interoperable. Okay. Providing interoperability between IoT platforms should not require the stakeholder to adapt to major changes in their system. So in order to make my devices interoperable with other uh, devices, the solution that is given to me should not be such a major solution that I have to change everything. Okay, so that is one more challenge. Next challenge is this: there are currently several academia, industry, and standardization bodies aiming to solve IoT system interoperability. Interoperability. Okay, it is not likely that a common set of standard will be universally accepted, which will allow IoT devices and platform to work together. So right now, lots of different parties, okay, lots of different people in academia, industry, and these standardization bodies, they are all working to solve this issue of interoperability. Okay, so all of these people will come out with different solution, right? So next problem will be how to make this solution interoperable. So that will be one more problem. There will be lots of different standards, and all these people will use this different standard. So this is going to give rise to more problem. If there were one standard, okay, one interoperability solution, then that would not have been a problem. But now uh, all this interoperability solution will be we will need to make them interoperable. So that will be one more challenge. Then the interoperability testing needs to be automated to inspire small businesses to develop interoperable solution. So right now testing is a very major issue, where if I used to test interoperability of two different system, then people, stakeholder from these two different systems has to sit together and test the system manually. Okay, so some automatic process to test this interoperability solution is going to make it what easier for small businesses to develop such kind of solution. Okay, so these are several challenges that we have in interoperability in IoT. So with that, we have come to the end of this video. So go through the slides, read everything properly. I hope you understood everything. uh, the remaining topic in this module, okay, was Arduino, Raspberry Pi and Python. My objective with these three topics, Arduino, Raspberry Pi and Python, was to demonstrate this in lab also. Okay, so we had just recently we started this IoT lab, and we did not even get the chance to inaugurate it. That is rather sad. I thought in this subject we will be using all these equipments that are available in the lab, but then because of this lockdown, okay, now it has almost been, I don't know, 40 days into lockdown. Okay, so because of lockdown we are not able to utilize those things. So my objective, that was to train you with real Arduino, Raspberry Pi, and to train you on how to use Python to work with these devices, that remains unfulfilled. So since we cannot do anything, uh, I have given you two assignments a few days back, in which the first assignment was that you had to write a 1,000-word essay on each of Arduino and Raspberry Pi, and the second assignment was that you had to, in your laptop, write a Python program. I even gave you a hint of a library, PyBlues, using which you have to communicate with using Bluetooth. Okay, so you have to communicate with your mobile Android mobile phone. So you can use this app called BlueTerm in your Android phone to test whether the connection is successful. So these are the two assignments that you have to cover up the rest of the module. Okay, since we cannot go ahead and use a lab to learn these things. Okay, so anyway, I hope you understood everything in this video regarding interoperability in IoT. If not, you can of course WhatsApp me, you can mail me, or you can write your doubt in the comment section below. Go through the slide. The paper that I used in this video has been given in this slide. Okay, so see you in the next video. Thank you.